Yeah, completely fine, sir. You can go ahead.
Good morning, one and all. I welcome you on the third day of our refresher course on Arduino and its application. I hope that you are comfortable and trying to enjoy the session, and also it is going to be a good value addition in your experience on your platform. I now request Mr. Sujit War, our resource person, to take over the session and continue the proceedings. Thanks.
Thank you, sir, for such a warm welcome. And as we know that we have to start with today is the third day, and we have to start with the quiz explanation of yesterday's quiz explanation will take place first, and then we'll go with the contents which are going to be delivered today. And after that, again, there will be a quiz on the topics which we have studied. So, yesterday's quiz, I was supposed to cover the topics with respect to the programming functions, but I could not complete that. So, most of the questions answer will be delivered in today's session, but still, we will see the questions, those who are absent. So, for them, please, we will see the questions, what questions which I have asked in yesterday's session, and we'll have the explanation of that quiz as well, so that it will help in programming of LED and LCD in today's part as well. So same concept we have to apply for the programming. So today I'm going to deliver about the LED programming architecture part, only diagram part which I missed yesterday in yesterday's session. I'm going to cover that, and after that we'll have the focus on. Okay, let me go with the schedule first, so that it will be easy for you people in order to know what we are going to study. So in today's part, the schedule has been displayed on your screen. So let me confirm first that whether I am completely audible and whether the screen is completely visible. So let me have a poll for that. So I'm going to publish the poll for that. So the poll will be for live for the 20 seconds. Please poll whether the screen is completely visible and am I audible, so that we can go ahead. Okay, thank you for your prompt reply. So those who haven't getting the proper voice as well as screen is not visible, then please reload the session or refresh the page. Thank you for your prompt reply, everyone out over there. So yes, today we are going to cover the architecture diagram, which we have missed in yesterday's session. Today we'll cover about the Atmega 328P GPIO and digital input output, and after that we'll have focus on LED and LCD. Maybe today's session will be bit lengthier, might be by 15 or 20 minutes. So please cooperate and do attend the session till the end, and after that we will have a quiz of 5 questions based on today's session, so that we can match up with our expected schedule. So let's start with the schedule. Let's start with the session, and here I'm going to have the quiz first. So the question which was first, the sequence of the question might be different which you have attempted yesterday. So, but all the questions I'm going to cover here. The first function which was asked here, the function delay counts the values of delay in. Now you are going function, delay function, in the programming part. So the syntax of delay function is always written in this fashion. Delay in bracket. Suppose I am writing delay in bracket 1000. If this is the value, this is an integer value, then 1000 it indicates that this delay is in terms of milliseconds. So 1000 milliseconds delay I am providing in during my program execution. So 1000 means it's simple, it's 1 second. So questions based on this can be asked in the exam, that yes, you have to provide some delay while blinking the LED and like that. So students should be familiar with the function and its syntax. So my request for the rest of the users, will you please mute yourself so that the background noise will not interrupt us or will not disturb us during the session. I have unmuted all of you, but please do mute yourself from your end. Whenever we require, we will definitely go with you and will have your you will have an opportunity to speak as well. Next function, the function pin mode in Arduino programming is used for. Now again, I haven't told you in the yesterday's session about the syntax of pin mode. So today I am going to cover about this pin mode function. So pin mode function is mostly useful in case, mostly useful, or I would say, rather I would say it is dedicated for the configuring the direction of the pin. So that part also I am going to cover, and its syntax as well. So here the syntax is in this fashion: pin number, then comma, you have to write down its status as input or output. So mostly this is useful in setting the direction. Mostly I would say yes, it is used for input or output direction of that particular pin. So this pin can be an analog pin, or this pin can be a digital pin as well. So in today's session also I am going to cover this. So here they have simply asked the function pin mode in Arduino programming is used for. So it is used for to change the input or output mode of a particular pin. So that should be your correct answer. Next, what does GPIO stand for? So generally we use this short form, but most of the students till the end of session, till the end of semester, they don't know about GPIO. So make sure that students should know about its proper long form, general purpose input output pins. And then followed by, we do have next question, a function. Here they are asking about the definition. A function is a series of programming statements that can be called by name. Yes, it's a definition. And here they are asking the question, which command is called once when the program starts. So yesterday in the programming concepts, I explained all of you about there are two basic functions or the structure in case of Arduino IDE program. So void setup is the must, and second one is void loop. So whenever we used to call this function called as void setup, so this gets executed only once during its life cycle, while while loop function gets executed forever, number of times throughout the life cycle. So the correct answer is once, means only once we are calling that. So that's why only one time you can call it as it is a setup function, void setup. So that should be your correct answer. And next, PB6 and PB7 pins of Atmega 328P are used as. So make sure that students should know about this, that yes, there are two pins which are responsible for providing the crystal oscillator input. Crystal oscillator inputs are like a heartbeats which are given to the microcontroller. So it provides the crystal operating frequency, and the operating frequency is 16 megahertz of your Atmega 328P. So students at least know about this, that make sure that students should know about this, that yes, port B's 6 pin and port B's 7 pins are dedicated for the providing the crystal oscillator input. So this was the yesterday's quiz and questions related with those quiz. Questions which were asked in that quiz, I have explained them. Now today we'll focus on the architecture part. So let's go with the architecture part. Yeah, the diagram might be quite blur, and if it do not fit to the page, make sure that you have made a full screen. And those who are mobile user, you can hide the sidebar of the chat section as well as for the users list section, and make sure that the screen is properly visible. You can even scroll down the screen up and down in order to adjust the things. So here I am also going to list down the features of Arduino Atmega 328P so that it will help to understand the concept. So features of Atmega 328P. So this is the microcontroller which we are studying about, and we are just listing down the we are just listing down the features of Atmega 328P. So we are studying about the AVR CPU. This is the architecture which is incorporated in Atmega 328P and which is 8-bit microcontroller. So that's going to be your first feature, 8-bit microcontroller. Here you will find out the structure of RAM, and RAM, the size of RAM is 2 kilobytes. So second feature, you can simply write down 2 kilobytes. Flash. So this is nothing but your ROM memory, and here the ROM memory size is almost 32 kilobytes. So here you can make sure that just make it as a your one of the important feature. So this is static RAM. Then EEPROM, its size is 1 kilobyte. Just list down that is as a 1 kilobyte. So this is the important part which one should have, or the student should have, in order to focus about the architecture, because until and unless they don't come to know about what is present inside that single chip, I see, till that point, I would say there will not be any kind of interest in their mind. So make sure that architecture diagram, though it has never asked in the previous exam, but maybe asked in the upcoming exams. So make sure that students should know about this. Now again, we do have 3 inbuilt timers: TC0, TC1, TC2. And what is size of each timer here? TC0 and TC2 are 8-bit timers. So there are two 8-bit timers. 8-bit timers, here I will list down it as 2. And the name of them are TC0 and TC2. Next, one 16-bit timer. Next timer is 16-bit timer, and name of that number is 1 and name is TC1, like that. It has inbuilt ADC, which is a 10-bit ADC. Then here you will find out the block for the analog comparator. Then for the serial communication we require ULSAT 0. Then for the communicating with the external world, we do have a serial peripheral interface. It is also called as master synchronous serial protocol, and then 2-wire interface. It is also called as intra-IC communication, that is I2C protocol. So these are the modules which are responsible for to have the communication with the external world, and not the least the port D, port B, and port C. As we have studied that we do have only 3 ports in Atmega 328P. Port B has 8 pins, port D has 8 pins, and port C only has 7 pins. So there are in total 23 general purpose input-output pins which are available. But out of this 23, actually the port C only provides the 6 pins. One pin, that is PC6 pin, is dedicatedly used for the reset function. So we never use reset pin for the general purpose input-output operation. Let's focus on the upper part. So in the upper part, you can see the power section, then debugging section, that is programming section, and here the main important, that is the hard bit, from where the microcontroller gets the hard bit, that is the oscillator section. Oscillator section, then here you will find out the voltmeter, timer, and watchdog oscillator. So whenever I used to teach this to the students, I generally ask them to just have the diagram in this fashion so that it will be helpful to them to how to remember this diagram. So in this diagram, the AVR is the CPU is the heart of the microprocessor, and everybody tries to communicate with the CPU because CPU is the boss here and nobody can take their own decision. So keep in mind, just make sure that we do have 3 columns. In order to remember the concept, we do have 3 columns. So make sure that 3 columns, and then we do have the number of blocks. Just go on counting the number of blocks. 1, 2, 3, 4, 5, 6, 7. So like that, we do have 7 to 8 blocks. Okay, 8 blocks. So 8 blocks in each column. Each column might be here 9 columns each. So go on counting those blocks, and first just draw the blocks and then go on putting the letters into the block. That's it. So hope you have got the clear idea about the architecture and what part should be, uh, what we should teach to the students. That's it. So anybody having any doubt in the architecture part, you can ask in the chat section. I'm waiting for 10 seconds so that you can ask your question or doubt in the architecture part. And if no doubt, then we can go ahead. So till then, I would like to go with the next slide. You can ask your doubt, and I can again go back and will have your doubt explanation. Okay, so architecture part is important. Yeah, that's not why there is no A port. Okay, good question though. We do have Professor Karandikar sir from Army Institute of Technology. Thank you for this doubt, sir. Yes, it's about the manufacturer who manufactures the IC. The naming configuration is based on the manufacturer. So it's in their code about whether we have to start with port A or port B. It's up to them. But according to my knowledge, as we do have analog pins, and analog pins are named in this fashion. Analog pins have the name in this fashion. We do have analog pins such as A0, A1 until A5. Means we do have six analog pins are here. Six analog pins are here. In FDP, told that don't go in detail explanation with architecture. Hello, Naneshwar Gauri sir. I do give respect to all the faculties who have told you about the directions given in the FDP. I am here not going to cross them. So you have to follow the instructions which are given in the FDP. This is just a refresher course. So in the refresher course, at least you should touch those points. Was earlier for 8051 89C51. No, that's not the case, Bakliwal sir. That's not the case. It totally depends upon the manufacturer, because if you look at the even I have studied the number of microcontrollers. Even I have studied 8051. I have studied about the Atmel, that is you are studying about Atmega 328P. Then I have studied about the PIC microcontroller, PIC series microcontroller. Then I have studied about ARM Cortex. So every manufacturer decides about the number of ports, naming of the port, and the nomenclature of the pins as well. And all these manufacturers are different. So hope I have given the satisfactory answer to your question, Karandikar sir. If you are having any kind of explanation, then you can also go ahead with the explanation. But no, it's not. It's not the case that port A was earlier for 8051. No, this is not the case, Bakliwal sir. Sorry for this. Yeah. So let's focus on this. Yes. Anybody want to speak? Because I have unmuted you all, but if you want to speak, you can have the doubt in raise a question block, or if not, I can continue. And all of you, those who are listening to us, keep in mind, at any point, if I'm going ahead with whatever told in FDP, I'm not going to cross them. You stick with the instructions which are given in the faculty development program. This is just a refresher course. Yeah, and we are covering each and every point. That's it, according to the syllabus. So let's focus on the introduction. This is a very important point according to my side, and even the faculty should also take interest in teaching this point to the student. Introduction to the Arduino general purpose board. Until and unless students see this general purpose board, I don't think there will be a curiosity in their mind or the interest in order to study this subject. identify you, and the nomenclature is in this fashion, so that's why the name port A is not given. But this is not the case, because we do have port D as well, and for we do have digital pins as well, D0 to D13. So that's not going to be a valid answer to the question which was asked by Professor Karandikar sir. D0 to D3 we do have port D as well, so that's not a valid answer, Mahesh Patil sir. So let's go ahead with the manufacturer, and it totally depends upon the manufacturer. Yeah, hope I have cleared your doubt. Let's focus on that now. That introduction to the general purpose Arduino Uno board. So I have taken this image again from the same website, arduino.cc. You can have a look on that website, as well as this is also available on our website wikinote.org. So here you can see they have mentioned this from the clockwise manner, top of the order. So we have to start with analog reference pin. So this is orange color pin is analog reference. Here I have listed down that reference pin. Then we do have a digital ground. So a light green color pin is called as digital ground, and then followed by, you can see, a 0, 1, 2, 3 like that. So we do have digital pins. So there are 14 digital pins available, and those are numbering from D0 to D13. In that, the D0 pin is used for the serial communication, and it is used to receive the data, while the digital pin 1 is used for transmitting the data, TX. After that, you will find out here, I have listed down those things. So if it's not visible, make sure that you can zoom in the screen. At the right hand side, you will find out a plus sign. In that, you can go with the zoom in the screen. Then digital pins, as I said, 0 and 1. Then again, we do have a reset button. Then followed by, we do have an analog pin. The analog pins are here. 6 analog pins are listed down. So now my question is, can anybody tell me, if there are only analog 6 pins available, then this IC will be having which package? Means whether it comes with the 22 package, 28 pin package, or 32 pin package. Can anybody let down me this? Just answer this. Yes, great. And here I am not here to test your knowledge. Sorry for the inconvenience if you are thinking like that. But I think the session should be interactive session. At least I'm asking the question, you are replying for the question, and obviously, so you will be attentive, and obviously you will feel a bit interesting in the quiz part as well. Thank you, Pranjal ma'am, Mayuri ma'am, then Mahesh sir, everyone. Yes, correct. So yes, it comes with the 28 pin package. If it would have been a 32 pin package, then the analog pins would be 8 pins. So after that, we do have a power supply section like that. Then we do have external power supply, 9 volt to 12 volt, power and ground, then external powering toggling option. Then yes, which is very important, USB, which is for uploading the program into the Arduino board. So general purpose Arduino board must be at least this diagram, then it should be, make sure that this board should be visible to the student. You should show them this board in the classroom as well as while in the practical sessions as well. Next, after that, we do have the pins which are related with the digital input output pins and then analog pins. Just we have listed down them here. So just here, analog input pin 6 for the DIP package, 8 for the quad flat package. Then how much DC current can be sourced or synced by a particular pin? It's almost 40 milliampere, flash memory 32 kilobytes, RAM 2 kilobytes, EEPROM 1 kilobyte. So mostly here they have mentioned used on most recent board, the controller which we are studying, ATmega 328P. So that's it. So this is a general purpose Arduino Uno board, and we have listed down with the help of examples as well. So anybody having doubt, they can ask in the chat section with respect to the general purpose Arduino Uno board. Rest of the things I'm going to list down. Otherwise, I can go ahead. You have 10 seconds to ask. We do have 6 pins, or I would call it as a PWM channels. So these PWM channels are useful in order to control the speed of DC motor or to generate a duty cycle based waveform. So digital pin number 3, D3, D5, D6, D9, D10, D11. You can correct me if I am wrong, those who know about this, but according to my knowledge, I can confirm this from the datasheet as well. D3, D5, D6, D9, D10 and D11. So from the digital pins, these pins can be used as a output pins for generation of PWM wave. Yeah, done with this. Now, with respect to the analog pins, what are the functions which are present in the Arduino IDE? Now, this is a bit challenging part according to me because most of the students will get confused between this, that what is the Arduino IDE and what are these analog pins and all. So keep in mind, make sure that students should have the concept clear in their mind. Arduino IDE is the software which is used to program the Arduino boards. And in the Arduino IDE, we are going to use certain functions in order to program the analog pins as well as digital pins. So here I have listed down the analog in as from 0 to 5. So nomenclature, you know that about this now, A0 to A5. Then analog output pins. Now keep in mind, input pins means data is coming towards the microcontroller, and analog output pins means data is going out of the microcontroller. So here, suppose this is my Atmega 328P, then if I am configuring A0 to A5, suppose I do have the pins from A0 to A5 in this fashion, so data is coming towards the microcontroller. So then we can say that these pins are configured in the input direction, and analog output pins D3, D5, D6, D9, D10, D11. Now the question comes into the mind. These are the digital pins, and though they are performing the function of a analog pins, so these are the analog output pins, but these digital pins can have a multiple rows as well. Okay, so don't get confused. Yes, D3, D5, D6, D7, D10 and D11, all these pins can be used as an analog output. So they will provide us the output, and that output will be in the form of PWM waveform. And everybody know about the PWM waveform. This is just a varied duty cycle waveform. So we can vary its T on time period. So I will explain that part into the DC motor control. Will not go in that much depth. So hope you are clear about the analog input and output pins, listed pins. Now, which are the functions which are related with the input part, and which are the functions which are related with the output part? So these basic functions are very useful in order to interface the sensors, to interface the DC motor into the second unit. So students at least know these things, and make sure that please explain that part with the help of an example. So input function, there are two functions with respect to every analog. With respect to analog pins, we do have three functions. So first function is suppose analog read, second is analog reference, and third one is analog write. Okay, so I would like to go with the example now. Analog read. Yes, suppose you are interfacing a particular sensor. So here I am interfacing a sensor, suppose LM35. I have interface LM35 temperature sensor to the A0 pin. So continuously A0 pin of Atmega 328P is receiving the data. But what is role of that analog read function? So what this analog read will do? So analog read, and make sure that we have to write down it in this fashion only. Everything is in small and R is capital. So these are the inbuilt Arduino IDE functions. These are the case sensitive functions, and we can't change the syntax which is present inside the microcontroller or inside the Arduino IDE library. So make sure that you have to make habit of writing the functions in this fashion only. So this is the inbuilt function provided by the manufacturer, and you have to go in this fashion only. I can't go entire capital or entire small. I have to go in this fashion only. So analog read, yes, I will write here A0. So continuously through A0 pin, I am going to receive the data. I am going to reading the data, and this data I am going to store at particular variable. So yesterday I explained about the concept of variable. So here val is the name of variable whose data type is integer. So this function, what this function will do, it will obviously convert the incoming data into the 0 to 5 voltage level always, and it will always provide the value between 0 to 1023. Now again the question comes into the mind, why the value is 0 to 1023? Okay, and that part I will explain at the time of ADC in ATmega. So at the time of ADC in ATmega 328P, please remind me about explaining this concept, why the value is 0 to 1023. Because some of the parts you are just collecting the information in this session, and some of the parts will get explained in the next session. So I'm not going to left behind a single bit. I'm going to explain each and every point. So do attend all the 5 sessions. So now here, yes, what is its function? So analog read, analog reference. So these are the two functions which are related with input. So analog read will convert the 0 to 5 voltage to a 10-bit number. So this value is always gets stored into the val variable. Then analog reference. Now this is used to change how voltage is converted. Now this is with respect to advanced, and we never use analog reference type function. Output function, yes, this is for importance for us, that analog write. So analog write, this is useful in generation of the duty cycle. So analog write, again, make sure that everything is in small, W is in capital. So analog write, then followed by, we do have a digital pin number, and then followed by the duty cycle value. Here I would like to write duty cycle value. Now for this you have to study one formula, simple formula, and the pins can be only 3, 5, 6, 9, 10, 11. And these pins we can't change. We have studied about this. Only these pins can generate a digital PWM signal. So this is the pin number, and then followed by duty cycle value. So this is going to be our example. Now duty cycle value, this value is in terms of 0 to 255 only. Now the question comes into the mind, and for that I would like to take you to the whiteboard screen. Now whiteboard screen is in front of you. Now why that value is only 0 to 255? Can anybody elaborate me about this? Why this value is 0 to 255? Okay, Gujar sir. Yes, correct. 8 pins is the wrong answer, Gujar sir. 8-bit is the correct answer. Your microcontroller ATmega 328P is an 8-bit microcontroller. Yes, correct. 2 raised to, yes. So 2 raised to 8 will give rise to 256. So this many combination we do have. So that's why it always starts counting from 0 to 255. So we do have 8-bit microcontroller. Most of the resistors in microcontroller, yesterday we have seen that general purpose resistor, almost R0 to R31, every resistor is an 8-bit resistor. So that means they can have the maximum decimal value of 0 to 255 that can be stored. So if you look at the 8-bit resistor, in simple words, 8-bit resistor, so everyone is faculty here, but still I would like to go with the concept. So if I am having the value in this fashion, so all ones are stored. Suppose 8 ones are stored, then 4 and 4. Yes, 8 ones, so 2 raised to 8. That means I can have 256. That is the maximum value, this decimal value that can be stored in an 8-bit resistor. So that is the explanation of this. So let's go ahead with this analog write part now. So in the analog write part, what is important? So in the analog write, I am going to write the pin number. Suppose I am using pin number 3, then followed by, suppose I am writing 255 value. So duty cycle are in this fashion that 255 value is written for the 100% duty cycle or 100% T on time period. 255 value is written for the 100% duty cycle waveform. So again the question comes into the mind, what do you say? So here I would like to tell that in case of 100%, keep in mind we do have a waveform in this fashion. So T on time is continuous. But if you look at this square waveform, then you will find out, yes, here T on and T off time has been balanced. T on and T off time period is completely same or equal. So at that time, I would like to go with 128 of value. This is for the 50% period. Keep in mind this 10% is the T on time period because duty cycle has the formula duty cycle or the percentage duty cycle is always written in this fashion. T on time period upon T on plus T off multiplied by 100. So here, suppose I want to generate a 10% duty cycle, that means my on-time period is going to be almost 10%, only 10%, and the off-time period is going to be a 90%. So here I'm just drawing the waveform for the 10% duty cycle. Make sure that the concept is clear, crystal clear in your mind now. That 10% duty cycle. Always keep in mind the T on plus T off time, that is the complete time period, or I would call it as a T time period. So this is always fixed. Only I am varying the percentage of on time period. So for the my question is for the 10% duty cycle, what will be the value that can be loaded into the analog write function? This is my question from my side. Okay. So, okay, great, Gujar sir. Yes, correct, exactly correct. So it's 25.5. So you can go ahead with 25, either 25 or 26 value. So here I have to load 25 value. So this function will generate a PWM waveform of 10% duty cycle onto the digital pin number 3. That's it. So this is the explanation. So let's go ahead with the document. So we do have three functions with respect to analog pins. Just we have to list down them and we have to study about the functions. What does those functions, inbuilt functions do? Okay, so that's important. And yes, Gujar sir asked me the question. Okay, question that whether we have to use a single pin in order to interface LM35. That part I'm also going to cover in the LM35 interfacing, but still, yes, it's a curiosity in his mind, so let's go with that concept as well. That if suppose this is an Atmega 328P microcontroller, then I am having the structure of LM35 in this fashion. So this is a temperature sensor and it is a 3-pin device. So which 3 pins it do have? So it has a VCC, it do have a ground, and third one it do have a output pin. So we will call it as a A out, and this pin is interfaced to the A0 analog input channel pin of Arduino. So only individual pin is used, not entire 6 pins are used. But if suppose I want to interface 6 different temperature sensors, then I have to interface them to the different pins, individual pins. Yes, that's it. That's the explanation. Hope you have understood the concept. Now again, the question comes into the mind into the analog read function. You have seen that what does this analog read function do? It converts the 0 to 5 voltage value into the 0 to 1, 0 to 2, 3. I have to explain this concept in the ADC in Atmega, but I could not resist myself because the question is asked in that fashion. So 0 to 1, 0 to 3 is going to be your decimal value, and here you can see that A0 is the analog input pin. Analog read pin will convert. It has the inbuilt ADC. Atmega has the inbuilt ADC. So here I would like to have the ADC structure. So inbuilt ADC, and this ADC utilizes the V reference voltage from the Atmega 328P itself. So we know that Atmega 328P operates between the voltage 1.8 to 5.5 volts DC. So same voltage, reference voltage is utilized by internal ADC. Same voltage is utilized by internal ADC. So obviously, any voltage which is between 0 to 5 volt, that can be sensed by the Atmega 328P microcontroller. If my voltage is between 0 to 10 volt outside voltage and I am providing this to the Atmega 328P, then I have to down convert this voltage in the 0 to 5 volt range. Even if my voltage is very less, then I have to bring that voltage level to have the voltage of 0 to 5 volt. That's it. So always keep in mind the operating voltage is placed voltage which we are providing to the microcontroller. And why this value is 0 to 1, 1023, that we have to look for, because we have to deal with one certain formula, and that formula is, suppose A out is equal to, I would like to write down this formula, that A out is equal to, we do have, suppose digital value, then we do have V reference, and we do have the resolution of ADC. So resolution of ADC. So we can go ahead with that in that fashion. So if you look at the resolution, what is resolution and what is digital value? So we know that what is final digital value? Can anybody tell me what is final digital value in terms of decimal? Decimal value. So we have studied the decimal value. First value is 0 and last value is 1023. I told you in the earlier features part, ADC is 10-bit ADC. So resolution is going to be 2 raised to 10 bit, and digital value, that can be maximum value, will be 1023 and divided by 2 raised to 10, almost 1024, multiplied by V reference voltage. Suppose I am considering it as a 5 volt V reference voltage. 5 volt 1023 divided by 10 cancel, and K out voltage is going to be 5 volt. So if I am using the analog read function, this will change the voltage between 0 to 5 volt, and it will convert it into the decimal value 0 to 1023. And why only into 0 to 1023? Because our internal ADC is of 10 bit. Hope everyone has understood the concept. The internal ADC is 10 bit ADC, so that's why the incoming voltage, which is being sensed by the A0, which is in the range 0 to 5 volts, gets treated or gets converted into the binary value, decimal value 0 to 1023. So you have 10 seconds to ask. You can ask me the question if anybody is having any doubt. And those who are still struggling with with my voice not audible and the screen not visible, they can reload the session. They can even join the session. You can close the browser and you can join the session again. 25. Yeah. Okay. Thank you, Rohan sir, for the prompt reply. Yeah. So let's done same to 15 part as well. I'm reading and able to have session. Can we go for the extended session of 20 minutes? I want permission from you. So I would like to ask everyone out sitting over there, at any point, let me know if it's boring, whether it's interesting. If it's interesting, then yes, obviously, you will ask me to continue. Thank you, Gujar sir. Whether it's interesting, let me know. It will motivate me to go ahead, and it will encourage me as well to share my knowledge with all of you. So at any point, if I'm making any mistake, I'm just your student. All of you are my faculties, and I'm just your student. So you can correct me at any point if I'm making any mistake. You can also share your knowledge as well. Thank you, Prasad sir, Karandika sir, Vaishali ma'am. Okay. Thank you, Vijay sir, Savita ma'am. Yeah. So, okay, let's go ahead then with the digital pins. So now this is quite interesting part, and if one knows about digital pins and all, then obviously he will feel interesting about the programming as well. Today I am going to teach you direct program, nothing special and all. So here, let's focus now. We'll list down the port and its pins as well. So port D, I don't want to make this session, thank you Rika ma'am, I don't want to make this session as our lecture, but yes, this should be an interactive session so that everyone at least can share their thoughts, and yes, we can uh, brush up our knowledge. So digital pins, we don't know, sorry, we know that we do have D0 to D13, so that means we do have 14 digital pins, and for that 0 to 7 you can see D0 to D7 belongs to the 4D, D8 to D13, this 6 pins belongs to 4B. Now can anybody tell me, in the very first part I told you port B, port C and port D. Now you are going to tell me, if it's interesting, then obviously you should take interest from your side as well, that port D has 8 pins, port C has 7 pins and port D has 8 pins again. So in total I told you at the features part that we do have 23 input output lines. But here they are dedicatedly saying these digital pins only 8 to 13, and we do have port B pins are from 0 to 5. So that means it is only from PB0 to PB5. What about PB6 and PB7? So I'm missing. I'm taking here 8 pins. I'm considering here 6 pins. I'm missing here 2 pins. Where that 2 pins went? Where this? No, yes, Rohini ma'am. Absolutely correct. Yes, very good. Yes. So, yes, it's really pleasing for myself as well, and it gives me a lot of satisfaction that yes, at least every one of you are getting the point, at least with respect to ATPIC 328P, and 2 pins are utilized for the crystal, and which are the dedicated pins. I can't use them for the general purpose input output operation. That's it. But if I am not providing crystal oscillator, then definitely I can provide. But yes, the crystal oscillator is the heart. It provides the heartbeat to the microcontroller. I can't left that unconnected. Next is 14 to 19. Then here we do have port C, and for port C we do have 6 analog input pins, that is from PC0 to PC5. One pin which is used for, can anybody list down? PC6 is used for, okay. So yeah, it's used for the reset operation, and even student will start taking interest in your subject if you are going to explain each and everything in the basic conceptual manner. So that's it. And we do have one onboard LED which is connected to the digital pin number 13. So onboard LED in the general purpose Arduino board, I haven't mentioned that, but we do have onboard LED which is interfaced with digital pin 13 in order to check the blinking of LED and all. Now what are the inbuilt functions which are related with the digital input output pin? Digital input output pin. Let me take you through the whiteboard screen, and onto the whiteboard screen I would like to explain those points. So in the functions associated, so these are going to be functions associated with whom? Associated with digital pins. Now with respect to analog pins we have listed down those functions. Now with respect to digital pins, what are the functions? So the very first function is suppose pin mode. Make sure that you should know about the syntax. Now in the quiz part also I have asked this question, so I am explaining those parts. Pin mode, then followed by next function as a digital write, and so these two functions are going to be output function, and the third input function is going to be digital read. This is going to be a digital read function, digital write and digital pin mode. Pin mode, role of pin mode is to say to configure its direction. So it's syntax in this fashion. So make sure that student know about the syntax. So we do have pin number, then followed by the direction of the pin, and direction of the pin can be input or it can be as output. Digital write, into the digital write section again the pin number, and here see here its function is write. Write means make sure that student at least know the idea of what is write operation and read operation. I would like to explain that with the help of a simple diagram, and then I would like to come here again for the explanation of digital write. So make sure that always for any microcontroller or microprocessor, this concept is always applicable. That if suppose data is coming towards the microcontroller. Suppose this is your microcontroller. So if the data is coming towards the microcontroller, then that operation is always treated as an input operation, or you can treat that operation as a read operation. Always keep in mind, data coming towards the microcontroller, this should be treated as a read or input operation. If the data is going outside the microcontroller, then that is always treated as an output operation or write operation. So data going outside the microcontroller, output or write operation. Data coming towards the microcontroller, this should be a read operation or input operation. So that's it. So here, so pin number. So we can, these are the functions which are related with the digital pins. So digital pins means binary pins, and we do have digital pin value, or digital value is always between 0 to 1. So that's it. Digital value can't be different. It is always 0 or either 1. It can't be intermediate value as well. So 0 means it's going to be a low and 1 is going to be a high. So here into the digital write pin number, then I can write either a low value or high value. So this is going to be a syntax. Similarly, in case of digital read now my question is, digital read, that means data is coming towards the microcontroller or going outside the microcontroller. Read means, digital read means coming or going. That's it. So yeah, obviously everyone can answer now. This is a simple concept, but yes, make sure that this should be taught, this should be taught to the students. So obviously that will help. Yeah, thank you, Vaishali ma'am. Everyone out there, correct? So yes, digital read means it's going to be incoming data. So here just you have to write down the pin number. So you have to write down just pin number, and you are going to read that data, and you are going to store that data into a particular variable. Okay. So here I have to mention a particular variable as well. So that part I will explain in the programming. So let's go ahead with the LED programming. So I'm taking your extended time, and all of you have already agreed for that. Thank you for that. So I would like to go with the onboard LED. So for that, we should have the interfacing diagram first. Make sure that students should at least know about the interfacing diagram. The controller here I am going to use. Now you are going to tell me which controller I have used, or which package which I have used, because I am most familiar with this package. Okay, Pranali ma'am is Pranjal. I don't know whether it's joke sir or joke ma'am. Sorry for that. Okay, everyone is saying DIP package. Let's see and recall those things. Okay, DIP package. Everyone. Okay. Madhuri ma'am is saying quad flat package 32 pin. Yes, Madhuri ma'am, you are totally right. Prajakta ma'am, totally right. So those who have told that this is a DIP package, though it looks like a DIP package, it's not a square, it's a rectangle, but keep in mind we have connected 2 pins to the VCC and 3 pins connected to the ground, so it's quad flat package, and nobody will tell you how should be your interfacing diagram. You can draw a circle also over here. Okay, no issues, because interfacing diagram, this is just a human made. But if you go with the hardware kit, then we have to specifically go for the rectangle or the quad flat package. So we do have 2 pins which are connected to crystal, followed by C1 and C2 capacitor, then crystal oscillator, and then we do have a ground connection which are 3 ground pins. So I am here going with the 32 pin quad flat package. And here, as we are going to interface the LED, and LED is an onboard LED. I am considering here onboard LED. We can interface LED to the any digital pin from D0 to D13, but don't choose the pins from D0 and D1. Why? Because D0 and D1 specifically performs a particular function, and you know about this. I have already told you about that. D0 is for the receiver operation and D1 is for transmission. You can use them, no doubt about that, but please have a habit of using the pins which are not having dedicated function. So it will, that is the symptoms of a good programmer, that whatever dedicated function is done by that particular pin, please provide or dedicate that function, particular digital function to that pin. So here, let's go ahead with the LED. So LED symbol, always keep in mind, it should be a light emitting diode. Most of the students don't draw the light emission sign, so it will be treated as a diode. So according to us, the student should not lose their marks. And here I am using as digital pin number is 13, so here D13. So this is onboard LED. You can interface LED anywhere. So this is the interfacing diagram, and here after the interfacing diagram, let me take you through the program, because you will start falling in love with the program, and after that I would like to take you through the algorithm. So let me know after that which part you like the most, whether the algorithm part or the program part. Arduino is pretty simple, but yes, our concept should be clear. So in the Arduino IDE, I told you that we do have two functions which are inbuilt in the structure, void setup, and make sure that if it's written in small, then we have to follow that only. Then, okay, then followed by we do have, now you are going to tell me these things, everyone sitting out over there, just interact with us so that the session will not be a boring session. So void setup. And the question is, data is coming outside the microcontroller or going inside the microcontroller? This is the LED which we have connected in. LED has two connections, one is cathode and one is anode. So in order to turn on this LED, anode pin should be at logic high, because cathode is connected to ground already, and it is permanently connected to ground. Cathode is already connected to ground. Yes, correct. The data is coming outside the microcontroller. So which function, Arduino IDE function, is responsible for configuring the direction of that pin into the outward direction? That no. Here we have to configure its direction. We can't simply write down the value directly. Yes. So its direction will be, and just write down the pin number. So pin number is 13, and followed by the pin should be configured in the output mode. That's it, and followed by the semicolon. Done. So this is the initial setup which I have to do. So I have configured the direction of the pin in the output mode. Now I have already. So which function should I use? Whether I have to go with digital write or digital read? Now I have explained you the concept of read and write operation. Yes. So I have to go with digital write function from absolute, so that data will come outside the microcontroller, and I have to just here write down the pin number, then followed by what should be the status of that pin. High, that means I'm sending high value to the digital pin number 13, and its LED will start glowing. Here LED will be turned on. I have to keep that LED turned on for a certain time period. Suppose I want to make sure that I have to make that LED should remain turned on for 2 seconds, then I have to use the function, inbuilt function, that is delay in bracket 2000. Here 2000 indicates 2000 milliseconds, and your LED will remain turned on for 2 seconds. Then followed by again digital write, and here I am going to write 13 comma low. Now tell me the significance. If I am sending low value to this pin, I am set to that LED, and they want immediately go from the action to on white, which we are writing it into the white loop. It is algorithm now. will also provide the full marks to the answer which student have written into the paper. Can we reverse the LED? Yes, obviously we can reverse the LED. But what will be changed, Mahesh sir? Okay, I will also will go with that. So here, make sure that your student should expected to write the comment. Comment will help them to understand the concept rather than just mugging up the concept. So they will write down the comment that yes, pin mode 13. So pin number 13 has been configured in output direction. So that comment should be written over here. Here, we are sending logic high value to the digital pin 13. That means LED on. Here, LED off. We are calling delay of 2 seconds. So they should know the concept. They should understand the concept rather than just mugging up the concept. Now the Mahesh Patil sir asked, yes, the LED. If I'm reversing the LED, I have to check that what should be the necessary connection. So I would like to go with his suggestion that in order to reversing the LED, and at the same time, suppose the LED is connected in this fashion now. Now, here I have to make sure that LED should be always connected to the VCC because this is anode connection, this is cathode connection, and this is going to be your LED now, light emitting diode. Okay, anode and cathode. Am I correct, Mahesh Patil sir? Are you asking for the same? The problems comes at assessment. Yeah, okay, no doubt. Student can draw the diagram in this fashion, no doubt. But make sure that anode is always connected to VCC. If you are connected anode to the ground, then it's impossible to turn on this LED. So if this is a digital pin 13, then in order to turn on this LED, I have to change here the value as 0. Because current always flows from higher potential to lower potential. So if it is VCC, it is at higher potential. So in order to close this LED, I have to send 0 value. So the code in order to turn I have on for low and off for high. Absolutely correct, Rekha ma'am. It's not a boring session. So let me simulation with the Arduino simulation. Hardly it will take next 5 minutes. So I would like to go with the Arduino simulation, and for that I would like to have the screen, getting my entire screen. Please just let me know in the chat section whether the screen is visible. Just let me know in the chat section that whether the screen is visible. Yes. Okay. Great. Because it takes a bit of time lag, so I would like to go with the software which is Arduino IDE and the Proti-State. So Proti-State is already installed in my laptop. A bit blurry will be there. It's screen sharing, and when I open the complete screen, then here I'm not going to teach you how to make a project and all, but I would like to show you the actual how to perform the simulation. So if anybody is interested, I can also teach him about how to create a project into the Protis and all. But this is not the time right now. LED Arduino, and make sure that you are making a proper, you are saving that into the proper folder. So triple E. And here I would like to write it as a simulation, and just I would like to save this. I selected the folder. Next. Sorry, here I am not going to explain any procedure and all. But yes, obviously, if you are interested, we can rearrange the session for the detailed explanation of this Proti-State and all. So keywords, I have already downloaded the library for the Arduino, and you will find out the Arduino Uno board which I do have right now. So I do have Arduino Uno board with me. So I just selected that. So this is the Arduino Uno board, and yes, you can rotate it into the X, Y, Z direction, clockwise. Yes, yes, great. And then I would like to go with the LED part, light emitting diode. I would like to make this screen zoom in so that it will be properly visible. Don't worry, I always prefer with the green light because I obviously afraid of the red light. Until and unless that green light glows, then it shows me yes, it's going in correct way. If it's red, then yes, it's going to be a khatra. So this is LED, green LED which I have taken and which I have interfaced to the digital pin number 13. And for that, I'm going to program this. So in order to program, I have to write down the program into the Arduino IDE software. I'm going to use the Arduino IDE software. So I would like to go with the Arduino IDE in the past. I do have already installed the Arduino IDE software. So here, in order to write down the code, I have to write down the file. So I would like to write down the code and just verify, and then have to don't go anywhere who are listening to us because see here, whenever I have opened the sketch, already it's with the void setup and void loop form. So this is the structure, input structure, and that is already present into your sketch. So here we have to just make sure that we have to provide pin mode. Maybe it's the font is too much small. Let me see whether I can increase the font or not. Okay, maybe I don't have that tool. So okay, so let me go with the so that it will be probably visible. Here I'm going to write down the code void. It's going to be void setup, and into the void setup we know that we have to take down the two curly brackets, then just shift enter, and here I'm going to write down the function. Make sure that you have to write down the function in the proper manner, syntax. We can't change the syntax. So pin number is 13 followed by how to configure it into the output mode. So I have written it instead of output. Okay, then we have to go with the void setup. After that we have void data loop, and into the void loop I would like to go with the next and that's going to be digital write, and into the digital write again W is capital, digital write, and we do have pin and its value. So here just I'm going to write high value, and that sorry I haven't given semicolon. The is a embedded C language, so it's a high level language, compiler level language. So make sure that students are familiar with this. So delay 2000, otherwise this code won't run. And just I would like to copy. I'm just a bit lazy guy with respect to the programming part. I would like to copy paste more and just make some certain changes. So no. Okay. So done with this, and just I would like to copy this and I would like to paste this into the Arduino IDE code. So I would like to paste the entire code into the Arduino IDE, and here you can see the pin mode has a red color, its color has been changed. Okay, here also I should have the output, so it should be written as a capital, so it will have the another color. Okay, so I can't go with the low value. Can you see the difference? If it was small value, small letter value, then it was showing me the error. So yes, done with this. Now you have to save the sketch, save as. So I would like to save this into the again desktop, and we do have already folder for that. Click to 2020 goes to the simulation. So under simulation, I save this. So just verify this. It will start compiling the sketch. You can see as compiling the sketch here the green symbol. And once we are done with that, so file in order to executable file, and the executable file is in a form. Let's see here that this is a .eno.hex file. So this is the path of that entire file, and I'm going to copy this. So Control C, I have copied this eno.hex file, and I have to write down this file into the 28 Arduino board. So this is virtual board in front of me. Just double click on this, and here I have to provide the program file path. So I have done that. Just click on OK. Everything is fine now, and just click on the run the simulation. So if it's closed, then yes, it's correct program. So can you see the blinking of LED, green LED? On off. Interesting. Let me know in the section. Let me know in the section whether it was completely visible. Can you see the blinking of LED? And it might be taking exact 2 seconds of delay. Just check with your watch, wristwatch. So interesting. So in the next session, I would like to take you through the LCD programming, its simulation. Okay, and don't worry, you will get the recordings of the session. You have to attempt the quiz as well. So hope it's interesting. It will not take you much time now, and I will stop this simulation as well. And I would like to go with the quiz part that time. So after quiz, I would like to ask Damne sir to address the session, and today you are going. And the time limit of the quiz is 2 minutes. So do attempt the quiz, and after that Damne sir will address the session, and he will allow us to wind up the session as well. So during the quiz I am not going to speak, so that will be a silence for 2 minutes. So attempt the quiz. I am going to publish the quiz. Your time starts now.